Today we are going to know about the batteries, basics of batteries. This is the symbol of battery. This one is positive, negative, positive, negative. So here positive, here negative. Batteries basic purpose is to storage charge. It is like that water, and this is water tank. This is charge. Here water, here charge. This is water tank, this is charge tank. So charge tank is, you can say, battery. Okay, so one charging and discharging of battery is known as one charge cycle. Means one charging, one discharging, we can say. Means in one side it will charge and in other side it will discharge, we can say like that. This is charge cycle, this is discharge cycle. So just for reference only, this one is charge, this one is discharge, you can say. So this is called one charge cycle. So inside battery this one is salt bridge, and this one is anode, this one is cathode. This one is charging supply is there. So electron will flow from this side to this side. Means from cathode to anode, from here cathode to anode, like this. This one is cathode to anode, so like this the charge will flow. So in this case, when charge will flow like this positive electrode is a positive electrode and this is negative electrode. So here is reduction and here is, we can say, oxidation. Means the charge will collect here. So this oxidation means reductant, means product plus electron. Okay, and in reduction, oxidant plus electron. So this is product, output is product. So in this case, loss of electron, and in this case gain of electron. So in reduction gain of electron is there. So when it is charging, so electrons from cathode side going to the, from negative to positive it is flowing. So this is called reduction, and this electrode has oxidation process. So oxidation means product plus electron. Before, when electron will move this side, that time it will become reduction here. So here will oxidant plus electron charge, so that is called product. So this is and one more, when it is connected across load, when it is connected across load, this is electrolytic, and this one is, you can see here, this one is electrolyte. So electrolyte, and this is salt bridge, same as it is, this one is salt bridge. And in during discharging, what happens, the electrons will flow from this side to this side, means from anode to cathode, from anode to cathode. So here reduction is there, positive electrode, and here oxidation is there, negative electrode. Oxidation and reduction and oxidation. So during discharging, from positive it is going to negative side, and in charging case it is like this. So here is a positive anode, electrode is oxidized, electrode is oxidized, electrode during discharging, and cathode electrode is reduced during discharging. So electrode is oxidized and oxidized during discharging, and cathode is reduced during discharging, means the electrons will come up this side, reduction, electrons will come up this side. So this side is a reduction curve, and here is a oxidation. So electrode is oxidized during discharging, you can see. So next you can say that's electrode. What is electrode? This one is the electrode, this one and this one anode, and this is cathode. Conductivity of ions, conductivity of ions between the electrodes, conductivity of ions, this is used for conductivity of ions, conductivity of ions. So conductivity of ions, and this is salt bridge. Keep two electrons connected, means two electrodes are connected by this salt bridge. This one is the salt bridge. By this two electrodes are connected, but keep them separate from each other. Means here is separate, here is separate. Okay, this point is separate, and this point is also separate. This point is separate and this point is separate. Means keep two electrodes connected, but keep them separate from each other. Means directly this electrode will not connect here. By this porous material, this will connected here. So it is a porous material, salt bridge. So next is rechargeable batteries. Rechargeable batteries. So first one is rechargeable battery, you can see lead acid. Second, this nickel cadmium, and third one is nickel metal hydride, NiMH. Then fourth one is lithium ion, and for fifth one is lithium ion polymer. This will used in mobiles also, and this will also used in mobiles, and this will also used in torches, and this one is normally used in homes, lead acid. And this one is also nickel metal hydride, also a type of battery. So next step is what are the parameters. Parameters are also there. Parameters of batteries. So parameters of batteries, first is a battery terminal voltage. Means terminal voltage by denoted by VT. So battery terminal voltage means how many voltage on the terminals. Charge storage capacity means AH, how much AH it will store, ampere hour. Suppose 150 AH, how much, example like that. Example, you can take 150, 100 AH and more also. And depth of discharge. Depth of discharge means how much depth, to how much depth you can discharge the battery, like 80%, 90% you can discharge. Number of useful charging and discharging cycle in numbers, like 1200, 1300 charging and discharging cycles. Means this battery will be charged how many times and discharge. So how many cycles? Cycle will become when it is one time charge and discharge. So fifth point is life cycle. Life cycle means what is the life of the battery in years, like 3 years, 4 years, there is life cycle. And self discharge, suppose if we are not using that battery, or how much is the self discharge, means how much it will discharge automatically by self. So this will be less than 1% in some period of time. So next is VEMF. VEMF, you can say VOC or you can say VL. This on load and VOC on no load. VL means load and VOC means voltage at open circuit voltage, means no load. So both are terminal voltages. VOC is on no load and VL on load. So this is called terminal voltage. And EMF is there, positive, negative, and some resistance is also there, RI, and this is the current I. This is RI is internal resistance, this is I is the current flowing, and this is the voltage drop across it, IR1. this is I. So this is the battery internal circuit, and when this positive and this negative, we can measure voltage here on battery terminals. This is called VOC. When it is connected on load like this, when load is connected, so that time it is VL. This is also a terminal voltage, so we are measuring on this. And cutoff voltage you can say, like, suppose this is the scale, this is 50%, 100%, this is 10%, suppose here. So how much means you can discharge this battery? If suppose this is the maximum capacity 100, you can charge up 90 here. Okay, this one is 10 only. So depth of discharge should be, suppose here I will give example. This is like full 12 and voltage, 12 voltage, and this is 6 voltage, this is 3 voltage, and this is 0 voltage. So cutoff voltage is this. Cutoff voltage is means it will cut off the voltage when battery will be discharged up to this, shown this part, means up to 3. If it is discharged up to 3 volts, so it will cut off the voltage. So this is its cutoff voltage. It will work only this area, means this will provide the charge when it is fully charged and down like this, and when it will coming 3 volts, it will stop the giving charge. So current produced by battery. So next is current produced by battery. Suppose it is how many Ah upon hours. Ah means suppose it is 100 Ah and we are using the battery 10 hours, so it will give only 10 ampere per hour. So how you can calculate, like power equals to VA. Voltage is 12 volts and ampere is 100, so it will give 1200 watt. And in energy case, voltage is same like 12, and in energy we can, Ah is coming like 100, sorry, this is ampere, directly you can calculate. So here 1.2 kilowatt hour we can say. So this is energy and state of charge, and this is depth of discharge. Depth of discharge, this is state of charge present. So this is battery. Suppose this is the cross, this is shown area is state of charge, means it is 75% charge and 25% is a depth of discharge, means up to this point you can discharge the battery, and state of charge is 75%. So you can take the charge only this part, and this part you will not take the charge. This part you can take the charge only this part, and this part you cannot take, means up to this point you can take the charge from here to here, and from this point to this point you do not take any charge, or the battery will not cut off from here. So C rating is the capacity means C in Ah, and this C in AH, and this number of hours in full charge or discharge. So you can find out the C rating by the capacity in AH and number of hours in full charge or discharge. AH, or you can say transfer efficiency. So this will you can find out by discharge energy upon charge energy. Discharge energy, charge energy into 100. So you can find out AH efficiency or transfer efficiency, or you can say battery efficiency. Okay, so battery for photovoltaic, first one is liquid vented. So liquid vented is a type. So in this, when this battery will charge, when this battery will discharge. So when this battery will charge, hydrogen release, and this when it is discharge, oxygen release. Second type is sealed or VRLA. VRLA means valve regulated lead acid. So VRLA means valve regulated lead acid.